All right, Chips Ahoy. In 1998, as an advertising campaign, the Nabisco Company announced a 1,000-chip challenge, claiming that every 18-ounce bag of their Chips Ahoy contained at least 1,000 chips. Dedicated statistics students at the Air Force Academy purchased from randomly selected bags of cookies and counted the chocolate chips. Some of their data are given below. So we got to check the assumption, create a 95% confidence interval, and then we're using our interval, we're going to test the hypothesis. Okay? All right. So the first thing you would do is you would put the data into a list. So put your data into L1. Okay? So that allows us to work through this. And of course, this problem is going to be a confidence interval, so we're going to use our panic approach. So what is our parameter here? Mu is the mean number of chocolate chips in, let's see, an 18-ounce bag of chocolate, of Chips Ahoy cookies. Alright, probably should capitalize Chips Ahoy. Don't tell an English teacher, it'll get all your nose all bent on a joint, but that's okay. Okay, so we have to do assumptions. So random. Okay, the bags were randomly selected. Independent. Okay, the number of chips in each bag is independent. Okay, 10%. Okay, in this case, what did they do? They bought 16 bags. So 16 bags is less than 10% of all bags. Chips Ahoy cookies. Okay? Normal. Okay. Well, 16 is not large enough sample that we can just assume that the sampling distribution is unimodal and symmetric. So, go to stat plot, turn plot 1 on, go to the histogram, and make sure you got the right list. I have mine in L1, and then do zoom stat. Okay? So, our distribution comes out, well, you say, well, Mr. O'Neill, it's not really, it's not perfectly unimodal and symmetric. Okay, it looks like it's a little bit skewed right. Well, it's not clearly skewed right. Okay. And let's see if I can change this window a little bit. Let's say that I change this to 1,000 and I go up to, I don't know, 1,500 and go up by 100. Sometimes you got to do this. Okay, there you go. So now I just got to change my Y max and change it to like 10. So now, are you happy? Okay, it's roughly unimodal. That's definitely unimodal and symmetric. So this is 1,000, 1,100, 1,200, 1,300, 1,400, 1,500. So we're going to copy that down. Okay, and it's going to look like that. This has to go on your paper. Can't just say, okay, I looked it on my calculator now, and we're going to say that the distribution is unimodal and symmetric. Okay, and this is 1,000, this would be 1,200, this would be 1,400, so forth and so on. So we put a little scale. Okay, name everything. Okay, this is a T interval. Where? What do we need? We need X bar. We need S standard deviation. We need N. And we need degrees of freedom. So, go to calculator. stat, calc, 1 bar stats, L1, boom, done. X bar, 1237.56. Standard deviation, 93.03. Degrees of freedom, N is 16, degrees of freedom is 15. Okay. Calculate the interval, I. Confidence interval equals X bar plus or minus T degrees of freedom times S over the square root of N. Okay. Confidence interval equals X bar 93.03 plus or minus, we got to figure out what T is. S is 93.03 over the square root of 16. Now, in this case, we're finding a 95% confidence interval. 95%, we shade the middle 95%. If I shade the middle 95%, that means I have 5% left. 2.5% there, 2.5% there. So that means that this interval starts at the 2.5% mark and ends at the 97.5% mark. So what we're going to do is we got to figure out what that T value is. So we go second distribution, inverse T. Okay, let me clear all this garbage out. Second distribution, inverse T. I'm going to use 0.975, comma, 15 degrees of freedom. And now we got our T value. Okay, it comes out to 2.13. Okay, so we put that on our paper. Now we got to calculate what the actual interval is. So you go to stat, test, and we're going to go down to T interval, number 8. Okay. Now I could just use data, I probably would. Okay, it's in list L1. Frequency is 1, 95% confidence interval, calculate. So 1188 to 1287. 1188 to 1287 is our interval. 1188 to 1287. Okay. Now conclusion. We are 95% confident that the mean number of chocolate chips in an 18-ounce bag of Chips Ahoy cookies is between 1,188 and 1,287 chocolate chips. Okay? So that answers question B. Okay? Now, question C. If I was doing a hypothesis test, my parameter we already talked about. We already know what mu is. So mu is this. The mean number of chocolate chips in an 18-ounce bag of chocolate chip cookies. I don't need to redo that. The hypothesis, okay? Well, the null hypothesis is that mu equals 1,000, okay? So the alternative hypothesis is they said that there's at least 1,000. So mu is greater than 1,000. That would be the alternative. Okay, so they said there's at least 1,000, so we want to know that there's more than 1,000. Okay, so is there evidence that there's more than 1,000? Because they said there's at least 1,000. Okay, so here's our interval. It's right here. So based on our confidence interval, what will we find for our hypothesis? Is there evidence that mu is 1,000, or is there evidence that mu is greater than 1,000? Well, if our interval goes from 1188 to, 1287, then what would we do? We would reject the null and accept the alternative, because 1,000 is not in our confidence interval. Our confidence interval is clearly above 1,000. It's closer to It's closer to between 1,200 and 1,300, so we would definitely read null here.